things that would like to be stars. We begin our journey with Earth, not too low, just to make sense of scale. The smallest things that have some star-like properties are large gas giants or sun-giants. Like Jupiter, the most massive planet in the solar system,
you're so
11
small.
times larger and 317 times more massive
calm down, I need to get worked
is made of the same stuff as our sun, just much less of it.
That went a little crazy.
The transition towards stars begins with brown dwarfs, failed stars that are a huge disappointment, tremendous amounts of energy. Stars that sequence stars. The more massive and more sequence stars, the hotter and brighter it burns, and the shorter its life is. Once the hydrogen burning phase is over, stars grow, up to hundreds of thousands of times their original size. But these giant phases only last for a fraction of their lifespan. So we can compare drastically different stages of their lives. This doesn't make them less impressive, but maybe it's good to keep in mind that we'll be comparing babies to adults. Now back to the star formation phase. When supermassive stars are born, they burn extremely hot and bright, and this blows away any extra gas that could make them more massive. So the mass limit for such a star is around 150 times the Sun. Stars like R136A1 are probably formed through the merger of several high-mass stars in dense star-forming regions and burn their core hydrogen in only a few million years. So this means they are rare and short-lived. From here, the trick to getting bigger isn't adding more mass. To make the biggest stars, we have to kill them. When main sequence stars begin to exhaust the hydrogen in their core, it contracts, making it hotter and denser. This leads to hotter and faster fusion, which pushes back against gravity and makes the outer layers swell in a giant phase. And these stars become truly giant indeed. For example, Gacrux. Only 30% more massive than the Sun, it has swollen to about 84 times its radius. Still, when the Sun enters the last stage of its life, it will swell and become even bigger, 200 times its current radius. In this final phase of its life, it will swallow the inner planets. And if you think that's impressive, let's finally introduce the largest stars in the universe. Hypergiants are the giant phase of the most massive stars in the universe. They have an enormous surface area that can radiate an insane amount of light. Being so large, they're basically blowing themselves apart, as gravity at the surface is too weak to hold on to the hot mass which is lifted away in powerful stellar winds. Pistol Star is 25 solar masses, but 300 times the radius of the Sun, a blue hypergiant aptly named for its energetic blue starlight. It's hard to say exactly how long Pistol Star will live, but probably just a few million years. Even larger than the blue hypergiants are the yellow hypergiants. The most well-studied is Rho Cassiopeia, a star so bright it can be seen with the naked eye, although it's thousands of light years from Earth. At 40 solar masses, this star is around 500 times the radius of the Sun and 500,000 times brighter. If the Earth were as close to Rho Cassiopeia as it is to the Sun, it'd be inside it and you would be very dead. To be among the largest we've found is Stephenson 218. It was probably born as a main sequence star a few tens of times the mass of the Sun and has likely lost about half its mass by now. While typical red hypergiants are 1,500 times the size of the Sun, the largest rough estimate places Stephenson 218 at 2,150 solar radii and shining with almost 500,000 times the power of the Sun. By comparison, the Sun seems like a grain of dust. Our brains don't really have a way of grasping this kind of scale. Even at light speed, it would take you 8.7 hours to travel around it once. The fastest plane on Earth would take around 500 years. Dropped on the Sun, it would fill Saturn's orbit. As it evolves, it will probably shed even more mass and shrink down into another hotter hypergiant phase, accumulate heavy elements in its core before finally exploding into a. generation of stars of all sizes.